Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்கள். எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Yes, good morning students, and today I am going to explain organic chemistry, particularly what are the reaction intermediates in organic chemistry. What are the reaction intermediates? Generally intermediates are carbocation, carbanium, free radical, carbene, nitrene, ylides, and next to benzene, and next to sigma complex. These are the reaction intermediates. The isolation of intermediates are sometime it is very difficult, sometime it can be isolated. Now write reaction intermediates. What are the reaction intermediates? Reaction intermediates. The reaction intermediates are in between substrate and product. In between substrate and product. Now in organic chemistry, first one is the substrate plus attacking reagent in the presence of solvent, and intermediates is there, intermediate or sometime transition state. We can term it as transition state after product is formed. This is the general reaction mechanism is applicable. Substrate plus attacking reagent. The reagent means maybe oxidizing, reducing, or OMC, organometallic. In the presence of solvent, what is the role of solvent? This solvent can be minimize the reaction between substrate and attacking reagent. They properly mix up in the reaction and to give product, more yield of the product. That is the role of solvent. Different solvents we can use. Water also one of the solvent, nitrobenzene and toluene, xylene, carbon tetrachloride, pyridine. Different solvents are we are using in organic chemistry. After intermediates are formed, intermediates are transition state. This is after intermediate. The lifespan is very less. After intermediate is converted to product. Generally the organic reactions substrate. What is happening in substrate? And the breaking of old covalent bonds in substrate, and making of new covalent bonds in intermediates. That is called organic chemistry. Generally organic chemistry means breaking of previous bonds and breaking of bonds to form breaking and making, that is called organic chemistry. What is happening here? The old covalent bonds in substrate is breaking. In the presence of attacking reagent, the breaking of old covalent bonds, formation of new covalent bond in intermediate. This is called organic mechanism it is following. Substrate, attacking reagent. The reagent may be either hydrogenation, either oxidizing agent or reducing reagent, anything. Solvent, intermediates are formed. We can take intermediates, number of intermediates are there. One is carbocation. Next one carbanium, and next one free radical. These are the reaction intermediates: carbocation, carbanium, free radical. Next one is the carbene, next one nitrene, and next ylides. Ylides also in higher classes we can phosphorus ylides in a Witting reaction, carbene, nitrene. We can take another one is the sigma complex. In sigma complex in aromatic electrophilic substitution reaction we can observe. Another one is the benzene. These are the reaction intermediates. What are the reaction intermediates, students? In between the substrate and product, one intermediate stage is present, that is the intermediate. Intermediate isolation sometime possible, sometime it is not possible in the case of free radical. Free radicals are highly reactive, they can react with another free radical because these are the odd electron species. The intermediates are carbocation, carbanium, free radical. Next one is the carbene, nitrene, ylides, sigma complex and benzene. These intermediates are involved in the organic reactions. Now we can discuss, there are two types of, in between the covalent bond is formed between two atoms. Mutual sharing of electrons between two atoms to form covalent bonds. In lower classes we can study what is covalent bond, student, and one atom giving one electron, another atom is giving another electron. This pair of electrons are mutually sharing between two atoms, that is called covalent bond. You know, ionic bond means one of the atom is losing electron, another atom is gaining electron. They are attained nearest noble gas configuration we can discuss in ionic bond. There is electrostatic force of attraction between two oppositely charged ions are formed between transfer of electrons from one atom to another atom, that is called ionic bond. Covalent bond means in between two atoms. If one atom, another atom, this atom give one electron, another atom give another electron, this pair of electrons are mutually sharing, that is called covalent bond. Now we can discuss in organic chemistry there are two types of cleavages. One is the homolysis, write down, homolytic cleavage. Another one is the heterolytic cleavage, heterolysis or heterolysis. Lysis means separation, breaking. Homolysis and heterolysis. Now take homolysis means, what is the name homolysis? This is the symmetrical cleavage of the bond. Symmetrical cleavage of the bond. Symmetrical cleavage of the bond. That is called homolysis. Homolysis means symmetrical cleavage of the bond. If I am taking A and B atoms, A atom and B atom, if it is symmetrical cleavage means this can be fish hook arrow, it can be represented fish hook arrow. Here is what is formation, A radical and B radical is formed. Radicals are formed. What are the radicals? A radical and B radical is formed. Why are A radical and B radical? Because here is symmetrical cleavage. Symmetrical means in between two. This is the same electronegativity is same. This arrow is a fish hook arrow. This name is the fish hook arrow. Fish hook arrow. That is a normal arrow remaining. This is the fish hook arrow. The symmetrical cleavage to form free radicals are formed. This one is the free radical. Odd electron species. It can be observed by electron spin resonance, ESR spectroscopy. We can write first to chlorine and chlorine in the presence of heat. Heat means delta and heat and light. This homolysis occurred in the presence of heat and light. to form, here is a chlorine radical plus here also chlorine radical. If you take bromine and bromine also, bromine, here also bromine, after symmetrical cleavage in the presence of heat and light to form bromine radical, here also bromine radical is formed. Bromine radical. If you take ethane, CH3, here also symmetrical cleavage in the presence of heat and light. Symmetrical cleavage is happening. CH3 radical, here also CH3 radical is formed. This is called homolytic cleavage. What is homolysis, students? Homolytic cleavage is a symmetrical cleavage of the bond. Symmetrical cleavage means this atom is giving one electron, this atom is the another electron. There is no electronegativity difference. These two are same fellows, same electronegativity, chlorine. But in the presence of heat and light to produce the free radical. What is the resultant product in homolysis? Free radical. Free radicals are formed. These free radicals are responsible for homolysis. Homolysis in the presence of heat and light. In the presence of heat and light. This is called homolytic cleavage. What is heterolysis or heterolytic cleavage? Unsymmetrical cleavage of the covalent bond. Unsymmetrical cleavage of covalent bond produces cations and anion. Unsymmetrical cleavage of the covalent bond. Unsymmetrical cleavage of the covalent bond produce cation and anion. Cation nothing but carbocation. Anion means carbanion. Carbon anion. Carbanion. Now I am taking A and A molecule, A atom and B atom. Here is B atom is more electronegative. What is electronegative? The tendency to attract the electrons. That's why A plus and B minus is formed. A plus B minus. The resulting products of heterolysis is carbocation, carbanion, cation, anion. Next one, if you take CH3Cl, in this case chlorine is more electronegative than compared to carbon. CH3 plus carbocation, methyl carbocation, Cl minus. If you taking CH3F, here also fluorine, CH3 plus and F minus anion is formed. This is called heterolysis. This is called homolysis. Heterolysis means unsymmetrical cleavage of the covalent bond. Unsymmetrical cleavage, one is more, because one atom is more electronegative, means they're trying to attract the electron cloud more towards itself. That's why here is chlorine is there, methyl is there. Chlorine is more electronegative, that's why it can be attract the electrons, this shared pair of electrons towards itself. That's why Cl minus, F minus. This is unsymmetrical cleavage. Heterolysis produces carbocation, carbanion. Homolysis produces free radicals. These are the two types of cleavages are observed in a organic chemistry. One is homolysis, heterolysis. Next we can discuss reaction intermediates. What are the reaction intermediates? The first one I am taking carbocation. Right, the students, What is the name? Carbocation. Carbocation. Now carbocation is formed due to heterolytic cleavage. Write down. Carbocation is formed due to heterolytic cleavage or heterolysis. Due to heterolysis, carbocation is formed. Now carbocation is, I am writing carbocation, this is the carbon is having positive charge, these are the p orbitals, positive charge, and now I am writing hydrogen, and these dotted lines are below the plane, and this dark line is the above the plane, and this one is the on the plane. Now write this one is the carbocation, one vacant p orbital. This one is the, how many sp3 orbitals are present? 3 sp2 orbital, not sp3, 3 sp2 orbital. This 3 sp2, this one sp2, these 3 sp2 orbitals are overlapping with 1s orbital of hydrogen. 3 sp2 of carbon overlapping with 1s orbital of hydrogen. 1s orbital of hydrogen. That is the sigma bonds are formed. 3 sp2. This one is 1 sp2. Now this carbocation, what is the hybridization, students? The hybridization of carbocation hybridization is sp2 hybridization. What is the hybridization? sp2 hybridization. Why sp2 hybridization? How many bond pairs are present? 3. 1, 2, 3. 3 bond pairs, sp2 hybridization. sp2 hybridization, what is the geometry? Trigonal planar geometry. Now here is incomplete, the carbocation is incomplete octet. Incomplete octet. It react with electron rich species, electron rich center or electron rich species. These are the important points of carbocation. Carbocation is formed due to heterolysis. Hybridization is sp2 hybridization, and trigonal planar geometry. Incomplete octet, because here how many electrons are present? 2, 1, 2, 3, 4, 5, 6. We can write the structure carbocation. CH3 plus. How many electrons? 6 electrons are present. That's why it is incomplete octet. It's react with electron rich species and trigonal planar geometry, sp2 hybridization. Now carbocation stability, a benzyl carbocation is more stable because of mesomeric effect. Benzyl carbocation after allyl carbocation, CH2 double bond CH2 plus because of resonance. Next one is the tertiary carbocation, means these are the methyl groups. Here also methyl, and next one is the CH3, CH plus and CH3, and next one is the CH3, CH2 plus, and next to methyl carbocation, and next one is vinyl carbocation. These are the stability order of carbocation. What is the stability order, student? Benzyl carbocation is more stable and allyl after tertiary, secondary, primary, methyl and vinyl carbocation. These are the important points of carbocation intermediates. Understand carbocation, how to form carbocation, heterolysis, unsymmetrical cleavage, sp2 hybridization, trigonal planar geometry. And next one is the free radical after carbocation. Next intermediate is free radical. Now I will write free radical. Write the free radical. Free radical. Free radicals. How to form free radicals? Due to result of homolysis. Due to homolysis, free radicals are formed due to homolytic cleavage. Free radicals are formed. Free radicals are formed due to homolytic cleavage or homolysis. Due to homolysis, free radicals are formed. Free radicals are odd electron species. Odd electron species. This is odd electron species, and electron spin resonance ESR spectra can be observed on the odd electron species, and it is also incomplete octet. Incomplete octets react towards other free radicals. What is happening? This is incomplete octet reacts towards other free radical, because free radicals are highly reactive. That's why they are reacting towards other free radicals. Odd electron species. Here also hybridization is sp2 hybridization. sp2 hybridization involved in free radical intermediates. And another one is geometry is trigonal planar geometry. As it is to carbocation. Here is the structure, means we can write here is carbon lone pair, one single electron is present, single electron. Now again this is the structure of free radical. Only odd electron, single electron species. Odd electron species, incomplete octet react towards other free radicals. And here also benzyl free radical is more stable than allyl free radical after tertiary, secondary and primary and methyl radical. The order of stability of free radical. Benzyl free radical is more stable because of mesomeric effect or resonance effect. And allyl free radical, tertiary, secondary, primary, methyl radical. These are the important points about free radical. Free radicals are formed due to homolytic cleavage, symmetrical cleavage. Each symmetrical means same. If two strong persons is that person two are sharing mutually, single. And free radicals are formed due to homolysis, odd electron species. This odd electron species can be observed by ESR, electron spin resonance. Incomplete octet, this is also not complete. Incomplete octet react towards other free radicals. Next, sp2 hybridization. Next to trigonal planar geometry, the stability is benzyl free radical is more stable. What is the reason? Because of resonance effect. These are the about free radicals. Another one is the Carbanium. What is the Carbanium? Another intermediate is Carbanium. Write down Carbanium. Carbanium. Carbanium is formed due to heterolytic cleavage. Due to heterolytic cleavage. Due to heterolytic cleavage. Heterolytic cleavage. Due to heterolytic cleavage, Carbanium is formed. How to form Carbanium, student? Due to heterolytic cleavage, Carbanium is formed. Carbanium is the organic ion having negative charge on the central carbon atom. Negative charge present on the central carbon atom. Right. The negative charge present on the negative charge present on the negative charge present on the central carbon atom. Central carbon atom. Negative charge is present. Now write the structure of Carbanium. It is like one is below the plane, one is above the plane, next to on the plane. Here is negative charge is present. Negative charge. It is similar to structure of the pyramidal shape. It is a pyramidal shape. What is the hybridization? Here is sp3 hybridization. What is the hybridization, student? sp3 hybridization. Now, due to heterolytic cleavage, Carbanium is formed. Negative charge present on the central carbon atom. That is, the negative charge is present, and it is a pyramidal shape and sp3 hybridization. What is the stability order? But here is benzyl carbanium is more stable because of resonance CH2 minus after methyl carbanium after CH3 CH2 minus, this is the reverse, and next to CH3 CH minus and CH3, and the least one is the methyl C minus methyl, here also methyl. Means benzyl is the more stable carbanium, after methyl carbanium is more stable. That is the reverse of carbocation free radical, because carbanium, methyl carbanium is more stable. This is the order of methyl carbanium. Tertiary is the least stable and methyl carbanium is the most stable. This is the brief explanation about carbanium. This is also one of the intermediate in the organic chemistry. Carbocation, carbanium, free radical. Which one is the more stable? Methyl carbanium. Which one is the least stable? Tertiary carbanium. That is the least stable. Next, coming to the another intermediate is carbene. Another intermediate is the carbene. Write the carbene intermediate. Carbene. That carbene is formed due to photolysis of diazomethane and ketene or ketene. Diazomethane and ketene, the resulting product is carbene. Carbene is the one of the intermediate. The photolysis, in the presence of light, it can be splitting. Photolysis of diazomethane and ketane, the resulting product is carbene. Write the carbene structure. CH2 double bond C double bond O. This is the carbene. We can write it in the presence of light. In the presence of light photolysis, we can write CH2. These are the carbene plus CO. Understand? This is the carbene structure. Next one, this bond is shifted to like this. This one is shifted. This is the electron deficient, neutral electrophile. This is the neutral electrophile, electron deficient. Lewis acids. What is Lewis acid? It can be accept the lone pair of electrons. It can be accept the lone pair of electrons. Donation of lone pair of electron is Lewis base, but it is a neutral electrophile. Dichlorocarbene and carbene are the neutral electrophiles. Another one, write down CH2 double bond N plus, here is minus charge, here is plus charge. Now in the presence of photolysis, in the presence of light, to form carbene intermediate, this is the carbene intermediate plus N2. To form the carbene intermediate is formed due to photolysis of diazomethane. This is the diazomethane, this is the ketene. The resulting product is carbene. This carbene is the neutral electrophile. Neutral, not positive. Neutral electrophile. What is electrophile? Electron accepting of lone pair of electrons, that is called electrophile. What is nucleophile? Electrophile is the electron seeking species. And nucleophile is the electron donating. Nucleophile is the to donate the lone pair of electrons, and it can be seeking the nucleus. Nucleophile is the seeking the nucleus. That is the difference. In this carbene, again carbenes are, there are two types based on singlet and triplet. The carbene can be divided into, then carbenes are divided into based on singlet carbene and triplet carbene. Here is how to decide triplet and singlet. The formula is there, 2s plus 1 spin. If you take a singlet, here is shared pair, unshared pair of electrons are paired. What is happening? Unshared pair of electrons, unshared pair of electrons are paired. Unshared pair of electrons are paired. Here is electrons are paired. That's why plus of minus of. One electron is plus of. Another electron is another one is a minus of. Plus of minus of 0. That's why 2 0 plus 1, that is equal to 1. That's why this one is the singlet, unshared. This one is the, what is the hybridization, students? Hybridization means 2 bond pairs, 1 lone pair. Total 3 na. sp2 hybridization. What is the shape looking? Shape is the bent shape. We can easily conclude it, bent shape. Why sir bent shape this one? Because after moving this, bent V shape. Another one. This one is the less stable. Singlet carbene is the less stable, bent shape, sp2 hybridization. If you go to triplet carbene, what is happening in triplet carbene? Here is unshared pair of electrons are not paired. Unshared pair of electrons are not paired. Not paired. Here is another one p orbital, another p orbital, another electron. Here is plus of again plus of. 2 plus of means 2, 1 by 2, that is equal to 1. Yes or no? 1 only. Now 2s plus 1, spin is 1 plus 1, that is equal to 3. Triplet. Now what is the shape it is looking? Linear shape. How many bond pairs? 2 bond pairs. That's why sp hybridization. This is highly stable. This one is the highly stable compared to singlet carbene. The triplet carbene is the more stable compared to singlet carbene. These are the one of the intermediates of carbene.